Okay, once again, you are welcome to my channel. I'm going to take you through these sample questions. We have these two questions which we are to solve. So the first question says, given that r prime of t equal to the exponential function of t, sine t, and then 6t, and we are to evaluate r of 0 equal to the vector, which is 2, 1, 3. And then the question 2 says that evaluate the definite integral starting from 0 to 1 of this. Okay, this is the function. So here we have solution. So to approach the first question, we have r prime of t equal to the exponential function of t, sine t, and then 6t. Okay, so we want to get rid of what? The derivative. So we have to take the antiderivative or the integral. Okay, so we have, introducing the integral sign, we are going to have integral of r prime of t dt equal to integral of e exponent t, sine of t, and then 6t dt. So here clearly you could see that when you find the indefinite integral of this, you are going to have r of t equal to the right hand side e exponent t. Okay, when you're finding the integral of exponential function, this one will drop, you can multiply, then you still have it the same thing. Then when you integrate sine of t, you should get negative cos of t. You should get negative cos of t. Okay, so you should get negative cos of t, and then 6. When you integrate this, you are going to get 6 t exponent 2 divided by 2. Okay, plus the constant. Okay, plus the constant c. So here we go ahead, you have r of t equal to this minus cos of t. This one will give us 3t exponent 2 plus the constant. So fine, now we've been able to find the derivative integral of this. We have to come back here and then do the substitution. So r of 0, which is equal to 2, 1, 3. Okay, so by doing substitution, we are going to replace the t with what? 0. So we have r of 0 equal to the exponential function of 0, okay, minus cos of 0, and then 3 multiply with 2 exponent 2, 0 exponent 2 plus the constant. So here r of 0 will give us the exponential function, okay, to the power 0 is 1. Okay, and then this one will give us 1, but remember we have negative here, so it will be negative 1. Then this one will give us 0 plus the constant c. Okay, right, now we have this to be equal to what? This. So we have to replace this one with this, okay, which is here. So we have 2, 1, 3 equal to 1 minus 1, and then 0 plus the constant c. So we have to transpose this one to the left hand side, which will give us 2, 1, 3 minus 1, negative 1, 0 equal to c. So clearly, if you perform this simple arithmetic here, you're going to get 2 minus 1, then 1 minus will give us plus 1, and then 3 minus 0 is still 3 equal to c. So here we get 1, 2, comma 3 equal to C. Okay, so here this is the answer to this particular question for the C. We have to go back and then substitute it here. So we have R of t equal to e exponent t minus cos t, and then 3t exponent 2 plus the constant that we just found, which is this. So it give us 1, 2, 3. Okay, so this is the final answer, or you can rewrite it in this form. Okay, which will give us the exponential function of t, that we add this to it, which is the I component. Okay, then minus cos t plus 2. Okay, and then we have here to 3t exponent 2 plus 3. So these are the final answer to this particular problem. So now let's move on to the question 2. Okay, the question 2 says that we are to find the integral of 1, 0. Okay, and then we have, sorry, I have to open it and then cross check it. We have 2i plus, okay, 2i plus 3j minus 6t. Okay, so now our next question, which is the 2. Okay, we are to evaluate. Okay, I just want to repeat the question here. Okay, 1, 0, 2i plus 3j minus 4t exponent 3. Okay, so you have to find the what? Definite integral of this. So from here we have the solution as it is. Integral of this 2i plus 3j minus 4t exponent 3k. Okay, dt. So when you find the integral of this, okay, it doesn't have t component, so we'll get 2t, okay, I plus this one to give us 3tj minus 4. Okay, when you find the integral of this, it will be t exponent 4 divided by the exponent. Okay, then we have the limit here, which will be what? The 0 to 1. So now here we are going to do the substitution. Okay, so we have k at 3. So by doing the substitution, we are starting from this. Okay, so we are going to have 2 multiplying with 1i plus 3, then j, this will go away, then we have 1 exponent 4. Okay, minus the lower limit, which is 2 multiplied with 0 I, so we have k here, then plus 3 multiplied with 0 j minus 0 expo 4 k. So clearly you could see that this place, the whole of this place will be 0. Okay, so let's focus on this part. That will be this time, this will give us 2i plus 3j minus 1 expo 4 is still 1, which will give us what? K. Okay, the whole of this place will be what? 0, 0, 0. So you know, when you perform the subtraction, you still get back this. So simply our final answer to this particular problem is, okay, if you are representing it in vector form, we are going to have 2 comma 3, comma minus 1. Yes, so this should be the what? Final answer to this particular problem. So thank you for watching this video. Subscribe, like it, share the link to your friends, and do not forget to hit on the notification bell. Whenever I update my video, you easily get the notification. Thank you once again. Goodbye.